Hello my dear students, today we are doing our lab for mass, volume, and density. This is in your Apex Unit 2 lesson. But before you do the actual lab, you should already have done the pre-lab worksheet. The worksheet PDF is on my webpage. You should already have done this prior to this lab. If you have not done this at this juncture, make sure that you have completed this sheet before you fill out the actual lab report. Okay? So we have two goals for this activity. Number one is for us to determine the volume of different objects by linear measurement. And by linear measurement, we mean we're going to use a measuring tool like a ruler. And also use another method of measuring volume of objects that don't have definite shape, like for example a bolt, which we cannot use linear measure to find its volume, and therefore we will adopt Archimedes' principle of water displacement, and so we will be using a measuring tool like the graduated cylinder to find the volume of an irregularly shaped object. Now, prior to this experiment, let us just link this lesson to a previous lesson we had before when you were still doing your Canvas assignment. Remember, properties of materials are divided into physical and chemical properties, intensive and extensive properties. For this particular experiment, we are measuring physical properties of materials because we are asked to find mass and volume and eventually the density of the object. These are physical properties because we don't have to observe a chemical change of the materials while we are measuring or observing these properties. Moreover, these properties are divided into intensive and extensive properties. And just to review, extensive properties are properties of materials that depend on the amount of the material. Like if you have longer bar, then it will have, of course, a greater length and greater mass. On the other hand, there are properties that are intensive. Those that don't depend on the quantity of the material but on the quality of the material. You will find later on that different metals, for example, will have different densities because of the kind of materials they will have. And that is one great application of this lab, because you will find that density, because it is an intensive property, can be used to identify materials. And that is one of the critical thinking part that you will have to be engaged with in this activity. So we have some materials that we will need for this experiment, and they are listed in your handout. I'm not gonna go over the list because they are already in your materials list. And I would just want to review some of the equations you will use to solve the problems and the properties that you are required to determine in this lab. Okay. First is the formula for volume of a rectangular object, and that would be length times width times height. And the volume of a cylindrical object like this rod, and the formula is volume is equal to pi r squared times L. R here is radius, and you should remember from your math class that radius is equal to half of the diameter. Eventually, you will use your calculated values for volume to find the density of the object, and density is equal to mass divided by volume. Consequently, you will use the formula volume of object is equal to the final volume of the combined materials minus the initial volume of the liquid, which is water, that we will use in this experiment. There are two parts to the lab. Part one is for us to find the density of the solids that I already have mentioned a while ago. And part two is to determine the density of two liquids: water, tap water, and a saturated salt solution. Okay? So I will perform the lab for you, and as you watch this video later on, you will take note of the values that are determined from the experiment and you will make the necessary calculations and then complete your data table and then answer the necessary or the appropriate questions in this lab sheet and then turn in your lab report. Okay, so let's start off with part 1 of the experiment, which requires us to find the mass of the 3 materials. So let's start off with the mass of the bar. And by the way, guys, I do not have an aluminum bar in the lab, and so instead of aluminum, we will be using zinc. So please take note of that. On your data sheet, you will replace aluminum with zinc. That is the bar that we are using, okay? So I'm going to use the balance right now to find the mass of the zinc bar. And the balance records 59.3 grams. Again, the mass of the zinc bar is 59.3 grams. Record that on your data table. Our polyethylene rod is this clear cylindrical rod, and its mass is recorded as 7.3 grams. 7.3 grams. And lastly, our steel bolt, the mass of which is 15.6 grams. 15.6 grams. Please record those data on your data table. I already have pre-measured our zinc bar and our PE rod, and on this whiteboard you will find the measurement of the dimensions. I will mention them to you, but if you can see them on the whiteboard, take note of them as well. Okay. The length of the zinc bar is 15.20 centimeters. Its width is 4.80 centimeters. Its height or thickness is 1.50 centimeters. You will calculate for the volume of the zinc rod by using the formula volume is equal to length times width times height. On the other hand, our polyethylene rod has a diameter of 1.10 centimeters and a length of 5.0 centimeters. The formula for the volume of a cylinder is pi r squared times length, but take note, I measured the diameter and you will have to calculate for the radius of the rod first before you can fit in the value for r in the calculation for the volume of the rod. Okay. Now, later on your own time, you will have to make the calculation for these volumes and make sure that you record all your calculated and rounded off final answers on your data table. Now we move on to part 4 of the experiment, and this time it is great that in science, especially in chemistry, there are ways to compare what scientists do. Like, you were able to determine the volume of the rod by calculation. But we can also determine the volume of the rod and our 2 other materials by measurement. And that would be using the water displacement method that Archimedes initiated long time ago. Okay, so instead, the procedure says use a 25 milliliter graduated cylinder. But because our rod is rather big, so for the rod, I will use our larger graduated cylinder. And to do this experiment, you have to have an initial volume of a liquid. And in this experiment, in most chemistry labs, water is used because water, although it is called the universal solvent, is not very reactive to the materials that we are using. It does not matter how much liquid you start with. What is important though is that you note how much of the liquid you have. And note guys how I am reading the volume. When you read volumes of liquid, you have to read at eye level, or you put your measuring device on the counter and then stoop down. You always have to read at eye level. And so at this point in time, our water in the cylinder is 300 milliliters. So in our equation here, your V initial would be 300 ml. Alright guys, so we have 300 milliliters of water in the graduated cylinder. That is your initial volume. So I'm gonna slide in gently. When you are using hard materials like the aluminum or the zinc bar that we are using in this lab, you have to do it gently so as not to break your graduated cylinder. So now we have to find the final volume of both the liquid and the zinc bar, and that is what your final volume will be. And now we have $315. I need a black background. No, that's okay. It's 315. So our final volume is 315 ml. Okay. All right. Now we will do the same procedure for our bolt and our PPE. I'm starting with 30 ml of water. I'm using the smaller graduated cylinder now because our bolt is smaller. Again, slide it gently. Make sure that the bubbles are dissipated because that might interfere with your reading the volume. 30, 31, 32, 33 ml. So our final volume is 33 ml. Our initial volume was 30 ml. Then you can calculate for the volume of the bolt. Okay, now let's do the PPE. Okay, I'm just gonna use the same volume of water which we initially used in the measurement for the bolt. I'm also using 30 ml of water as our initial volume. Now, PPE is the material that many of our plastic containers are made of. When I put this in the graduated cylinder, what do you think will happen? Will the cylinder float or sink? Now, what do we know normally of plastic bottles? Okay, they are light material, they are less dense, so most likely it will float. But in case it does float, that is why you have a steering rod just to push it in and make sure that it's submerged in the water so that you can get the final volume of the water with the object. Again, slide it gently, slowly. Oops, okay, it did not sink. So I guess our PE or polyethylene is not less dense than the water. Okay. I need to have to adjust the reader. And so our volume is 34. Always read at the lower meniscus, 2 for 36 ml. Okay, so our initial volume for the water is 30 ml and our final volume is 36 ml. Okay. And that is part 1 of our lab. Okay, I will just clean up some of our graduated cylinders and I'll get back to you to continue with part 2 of our experiment. For part 2 of our lab, we are asked to determine density of liquids. So you might wonder, but liquids flow, but how do we determine the mass of liquids that flow? But remember guys, in your current lesson in Apex, know that liquids occupy a space and they have definite mass. So if we can contain the liquid in a vessel like the graduated cylinder, we can use the balance to measure the mass of a definite amount of a liquid. And once you find the mass of a specific volume of liquid that we measure, then you can again calculate for the density of the object. Okay? So we will start by finding first the mass of an empty vessel, and for our vessel we will use this graduated cylinder. Okay. And our empty graduated cylinder has a mass of 132.0 grams. Again, the mass of our empty graduated cylinder is 132.0 grams. That is 132.0 grams. Now we will put in that graduated cylinder 50 milliliters of water, and we will find, by calculation of course, the mass of 50 ml of water. So I'm going to use a wash bottle to transfer 50 ml of water into the graduated cylinder, and we will find the mass of the water by subtraction, because now you have an empty container that has a mass of 132.0 grams, and now we are adding water into it. So what do you think will happen to the mass of what we have on the balance right now? Since we're adding another substance, then we expect the mass to be greater. Just a little bit more squirts. Okay, guys, always read at the lower meniscus of a colorless liquid. And note, I demonstrated to you reading at eye level, so you have to stoop down. So now the final mass of our graduated cylinder that now has 50 ml of water is 181.4 grams. Again, the combined mass of the cylinder and the water is 181.4 grams. Now you will calculate what is the mass of 50 ml of water, and once you find that mass by subtraction, you will fill out data table 2.3 and consequently calculate for the density of tap water. This is water from the tap, so it is water delivered to our home by NTUA. Now, we will do the same this time with a saturated salt solution, which I already have prepared earlier. And note the difference, guys. See, this is tap water and it is clear. Our salt solution, which is saturated, is translucent. Why? Because I have added more than enough salt that tap water is able to dissolve, and that is what we call a saturated solution. I have added enough salt until no longer dissolves in water. We will follow the same procedure, but this time we will be using a beaker, and we will find the mass of this 150 ml beaker. So the empty beaker has a mass of 69.9 grams. Again, the mass of the empty beaker is 69.9 grams. I will transfer in that beaker 50 ml of the saturated salt solution. And then we will find the mass of that 50 ml of saturated solution. Wow, that's perfect. Okay, so our mass is 123.2 grams. The mass of 50 ml of saturated salt solution is 123.2 grams. So there you go, guys. Again, fill in the data on table 2.3 and you will calculate for the density of the tap water and the saturated salt solution. The last part of the experiment you will have to do on your own, and this will require measurement of the dimension of your room wherever you are. If you are working in your bedroom or in your living room, wherever you're working at the moment you're watching this video, you will have to measure the length, the width, and the height of your room and calculate for the volume of air in that room. And then, given the density of air, we will assume that because it's cooler today because of the snow, and we are at 7,000 feet above sea level, we will use this density value for dry air. And I will just write it down here. The density of air at 29 degrees Fahrenheit and at approximately 7,000 feet above sea level is 0.7071 kilograms per meters cubed. Okay, now in this part of the lab, you will be asked to find the mass of the air that occupies the room that you are in. So you will have to derive the formula for mass given the density of the air, and after you calculate for the volume of the air that is in the room that you would prefer to make the measurement for. Okay, so you will complete the lab by answering the questions that come with the lab. Do not do the extension lab unless you are willing to do an enrichment activity. And if you would want to do the enrichment part, you will have to contact me and signify your intention. Otherwise, that is our lab, guys, and I will see you during our Zoom meeting tomorrow, Wednesday and Thursday. We will discuss this lab, and if you have questions, write down your question and ask them when I see you during our Zoom meeting. Okay? Hagone!